Okay, by now, hopefully you've watched the Khan Academy videos and practiced a couple problems setting sigma notation up. I'm going to show you some actual computational uses of sigma notation. Then I'm going to leave you with a couple of formulas that you should write down and have nearby, okay? So, what if I asked you to add up the first 10 numbers, okay? All right, we go 1 plus 2 plus 3 plus 4, 6, 7, 8, 9, 10, and we'd know that this looked like this, right? Sigma notation from 1 to 10 of I. All right, now we can add these up, 10, 19, 27, so on and so forth. And the first 10 are easy, okay? I believe the answer is 55, okay? But what if we wanted to do this and did 100 of them, okay? Well, 1 plus 2 plus 3 plus dot 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 plus 98 plus 99 plus 100. Well, that would be really, really a lot of work, okay? Well, there are some shortcuts. Don't know if you realize this from the first one, but watch. If I add the first and the last one, I get 11. And if I add these two, I get 11. And these are 11 and 11 and 11. Okay? How many 11s do I have? 1, 2, 3, 4, 5. 5 times 11. Okay? So there's some shortcuts that could happen. I mean, we could do it down here. Whoops. Use my eraser, not my... All right? That's 101. That's 101. That's 101. How many 101s do we have? Whoops. We have 55 of them. So 101 times 55 is obviously 5,050. Okay? Now, these are fun and easy, but we can actually derive the equations. All right? And it's kind of a cool little thing. So, that's what we're going to talk about. I'm going to give you some equations so that you don't have to add all these up. So here's 3 equations to start with. Okay. We start at 1 and we end at some arbitrary number. Did you notice how all of these, it was always an integer, right? 1, 2, 3, 4. There's no decimals, there's no negatives, okay? Well, how do we find out? What if n was 1,000, right? We could do it, but here's a really cool shortcut, and normally we derive this, but different times call for different methods of learning. So there's that guy. Remember how we had the one with 10? 10 times 11 over 2 equals 55. So that's when n equaled 10. All right? So that's a pretty cool formula. Well, there's other rules too. All right? We could have I from 1 to n of I squared. Now this one's a little harder to derive, so I'm just going to give it to you. N plus 1, and then 2n plus 1 over 6. So there's that guy. We'll do a really short example over here on the side. We'll go from 1 to 4 of I squared, which is 1 squared plus 2 squared plus 3 squared plus 4 squared. Let's see if we can do this. 1 and 4 is 5, and 9 is 14. So I think that's 30, right? Find out if I'm right in a second. But now if we plug it into this formula right here, okay, we would get n. N is 4. 4 plus 1 is 5, 2n plus 1, so that's 4, that's 9, over 6. So 20 times 9 is 180. 180 over 6 equals 30. So I keep doing that, sorry. So there's that one. Now there's one more that we'll give you, and that's the cube. Okay? Now the reason that we're learning or going over the sigma notation is that we're going to use it to calculate some things with our calculus, okay? With our integration. So we're not going to go over this too in depth. A lot of times there's not a ton of questions on the AP test about sigma notation, but it's kind of cool to lead us into the next step. All right, so there's the third one. All right, when we have I cubed. All right, so that's that. I got one more to show you. Okay, and this one's kind of cool. So let's screen down. What if I had I equals 1 to 7 of the number 3? Right? The rule isn't I or I squared or I cubed anymore. It's just 3. So what this means is I start at 1. What comes out? A 3. I go to the next number, 2. I get a 3. I becomes 3. I get a 3. And so on. And I do it 7 times. Okay? So here's our last rule for sigma notation. I equals 1 to n of, we'll call it c for a constant. You simply take c times n. Okay? Now, we'll run into some problems later on. I think you saw in the video, what if I start at 0 and go to 4, or something like that? How does that change? And we can talk about those on Monday, but this will be your last video of the day. If you want to try some problems at the beginning of section 4.2, let's see, 1 through about, I don't know, 44-ish. Okay, those are all sigma notation ones. But we're gonna learn this, and then we're gonna do something more geometric. Okay, so thanks for paying attention today. And the nice thing is you can watch these whenever you feel like it. All right, see ya.